So far, what we have learned in our simple linear regression are as follows: how to make a scatter plot to visually represent our data, how to graph the regression line, which visually represents our model, then our actual model, which is the regression equation. We also learn how to determine the strength of the relationship through Pearson R and R squared, the coefficient of determination. And this time, we will learn whether that actual relationship is significant or not. Because they might have a strong relationship, we might be able to have a regression line and a regression equation, but actually it's not significant at all, or that relationship is negligible no matter how strong it might be, because that strength might simply be due to the chance that we got it from our sample. So now we will do hypothesis testing on simple linear regression. And of course, when we do hypothesis testing, we need to follow 4 steps. And as we all know, for hypothesis testing, there we go. Number 1, we should be able to state our HO and HA. Number 2 and 3, we shall compute our test value and our p-value. And number 4, we should have our conclusion. So first, we have to know how do we state the null and alternative hypothesis in simple linear regression analysis. And here's how they look like. Null hypothesis: X is not a linear predictor of Y, or the alternative, X is a linear predictor of Y. Now, just to clarify, we said that correlation R does not cause causation, but that does not mean that X cannot be a predictor of Y anymore. If you're only using R, then we cannot have this. But since we are using rather the entire regression, then we can say that X might be a linear predictor of Y, or that X might cause Y. But of course, our null is that X is not a linear predictor. Now, how come that here X is not a linear predictor of Y is our null hypothesis? Because when we write it in symbols, it would be like this, that beta sub 1 is equal to 0, or beta sub 1 is not equal to 0. Let's see why is this so. If beta sub 1 is equal to 0, then the equation of the regression line rather, would just be a horizontal line. Which would mean the scatter plot might look something just like this. There's no direction going on. That's why we cannot have any strength at all. So there's no relationship at all because we cannot determine the strength, we cannot determine direction. That's why X here, it's equivalent to X is not a linear predictor of Y. Because of this situation that I illustrated here. Now, the alternative is here because if there is a slope that is not equal to 0, it can either be this, which is a positive 1, or this one, which is a negative 1. So either one of these two would result to our alternative hypothesis. So again, for our null hypothesis, even though it's not stated in the problem, because usually we are only given with the data, our null is that beta sub 1, or our slope is 0, while our alternative hypothesis rather is that beta sub 1 is not equal to 0. And now that we got that cleared, let's do hypothesis test on our running example on dexterity and productivity. So now we're going to do our hypothesis test in our regression in Excel. So we now go to data again, data analysis, And this time, let's take a closer look there. We shall now go to regression. Select that and we click OK. So now we have more things to input. So the first, it says input Y range. So let's do that. Let's select that and input our Y range. So it's important to remember what is our Y, and that is productivity. There we go. Then we should select our input X range here. So we select that. And our input X range is our dexterity. So there we go. Then once we go back and zoom that in, our labels, there is, so we check that. We leave the rest unchecked because we don't need that. Our output range, so we select our output range. We select here down below here. There we go. And the rest, we will not need them anymore. That's beyond the scope of our lesson. And once everything is okay, we click OK. And there you go, which we would have a lot, not a lot, but 3 tables. Let's look at them one by one. The first table is the summary of the regression that we would have. And as you can see, we actually have our R here and the R squared here. So, sir, can we just simply compute regression? And then it will give our R and R squared? Not quite. The reason why we can't just simply rely on regression to compute for R or multiple R here is because this does not give the sign. And when I say sign, I mean whether it's positive or negative. So it's better if we would use the correlation here so that we would know the sign. It's just that here the sign is positive, but we can definitely use this one for R squared. So here we have some of the other values that we don't need. They are for higher statistics. And as you can see, we actually have an analysis of variance. Why is that? The analysis of variance is actually analyzing the variance of each data point to our regression line. That's why there is ANOVA, because this is testing the difference or the significance of the difference of each data point to our line. And that's more than one. So that's why it used ANOVA. And here down below, we have actually some values that we would need. So if you will notice, the intercept here, this value is actually our beta sub 0, and here the coefficient 3 is our beta sub 1. And we need the p-value, so it's here. So now that we have shown how to use this one, or how to use Excel to give the output for hypothesis testing, we shall now put formally the steps of hypothesis tests in the next video.